Hello everyone. Today's unit is going to be on the metric conversion, something I call the loop chart. It's basically converting between one metric unit to another. For example, if you want to go from centimeter to meters or meters to kilometers, we're going to learn how to use this metric loop chart. So let's start off by drawing the metric loop chart here. Basically, just want to do a straight line here. Okay. And we're going to start off in the middle here. This is going to be our base unit. So what do I mean by our base unit? If we're talking length, our base unit is going to be the meter. If we're talking time, the base unit is going to be the second. There's all kinds of base units. Computer information is going to be the byte. And for electric current, the amp. All right, but anyway, the way we draw the loop chart, starting in the center with our base unit, is we want to count by threes. And we want the third hash mark to be the large hash mark. So we're going to go 1, 2, 3, 1, 2, 3. 1, 2, 3. All right. Now, when we draw it this way, we want this unit to be the larger unit. So the larger unit is going to be going to the left. So these prefixes make the unit larger, which means you have to make the number smaller. Okay. So when we're counting by these, each of these lines represents a place for the decimal. So if I start here, I go tenths, hundredths, thousandths. So this line represents 1,000 of something, which is going to be 10 to the third, and we call that kilo. So anytime you add the prefix kilo to a measurement, you're adding you say you have 1,000 of those, and that's abbreviated lowercase k. So a kilometer, kilobyte, kilosecond is 1,000 of something. Moving further out here, 3 more units is going to be 10 to the sixth, and that's going to be a million, and we call that mega. So if you have a megameter, you have a million meters, and that's going to be capital M. And moving 3 loops over to the left again, now you're talking very large. 10 to the ninth, that's going to be a billion. So once again, kilo's 1,000, mega's a million, and 10 to the ninth is a billion, and that's a giga. You've all heard of gigabytes, capital G. All right. Now moving this way is a prefix that makes the number smaller. So if you're making the number smaller, the prefix is smaller, you have to make the number larger. So we're going to count the same way. 1, 2, 3. 1, 2, 3, 1, 2, 3. Okay, and this is going to be milli, lowercase m, and that's going to be 10 to the minus 3. Well, if kilo means 1,000, milli means 1/1000th of something. And moving out here, you guessed it, 10 to the minus 6. That's going to be micro. And since you've already used lowercase m, you got to go to the Greek alphabet, and m in the Greek alphabet looks like this. It's the Greek letter mu. And moving out here, now you're talking the size of atoms and molecules, 10 to the negative ninth. That's 1/1000th of a meter, or 1/1000th of a second, and that's called nano, like nanotechnology. And that's lowercase n. All right, so these would be getting smaller prefix. Okay. One other important thing to mention here, all of these little hash marks also have names. These two in particular are important because they're on a meter stick, so we are going to name those. This one is a deci for decimeter, and this is centi for centimeter. So we do need to know those just because they're so common on a meter stick. That got hecto and deco for these other things. And this loop chart goes way beyond in both directions. Getting smaller, you have femto and atto, but those are units we're really not concerned about. One other side thing I want to say, something called derived units. When you combine 2 or more units together, a real common one we use in chemistry and in geoscience when we're doing density is volume. Volume simply the amount of space something takes up. It can be a liquid or a solid. Okay, and a common unit we'd use for volume is the milliliter. Usually we just write ml for milliliter. And what we need to know is 1 milliliter, ml, is equal to 1 cubic centimeter. So whenever you see cubic centimeter, it's synonymous with milliliter. Usually solids are given in cubic centimeters and liquids in milliliters. Okay, the standard unit for volume is a cubic meter, and that's just a really large volume. We use that in physics, but most of the time in the lab, such a large volume, we put things in milliliters or cubic centimeters. Another common unit we have for volume is also going to be the liter. 1 liter is the same as 1 cubic decimeter. So a decimeter is about this big. So if you imagine a box this big by this big, by this big, filled with liquid, that's going to be equal to 1 liter. Okay, so let's put this into action here. Let's try a few practice problems using the loop chart. Okay, so let's start off. Let's say I have 558 kilometers, and I need to convert that to meters. So we go to our loop chart here. So I'm at kilometer, and I want to go to meter. So I'm going to go 1, 2, 3 loops to the right. That's why I'm going to move my decimal. Okay, so my decimal is not written on here, but it's assumed to be at the end. So if I start right here at kilometer, if I want to go to meter, I just move it the same way, 3 loops to the right. And then in this case, I'm going to have to add 0. So my final answer is going to be 558,000 meters. Okay, you don't need to put your decimal at the end. We'll talk about why that is, but just writing it like that is fine. Okay, let's try another one here. Let's go 55 centimeters. This is a real common one you would do in a lab. You measure something to be 55 centimeters, but you got to put it in a formula where it's in the standard unit of a meter. So convert that to meters. So you say, okay, here I am at centimeter, and I got to go to meter. Tens, hundreds to the left. So 2 loops to the left, that'll take me to meter. So here's my decimal at the end. 2 loops to the left, I put it right there. My final answer, 0.55 meters. So what that says is 55 centimeters is the same as 0.55 meters. Okay, they're the same exact thing. So sometimes you need to convert it to the standard unit to put it into some formula. All right, let's try another one here. Let's do 230 milliseconds. So if I have 230 milliseconds, and let's say I want to convert that to seconds. Okay, so here I am at milliseconds, and I want to go to seconds. I'm going to go 1, 2, 3 loops to the left. Final answer, 0.23, you don't need the 0 on the end, lowercase m, seconds, not capital M, that would be megaseconds. Okay, so there's a few examples. So once again, it's important that you draw the loop chart in this order so that you move the decimal the correct way. A lot of times books will put nano on the left side and gig on the right side. They do that, and you can't really use it in a useful manner of moving the decimal. So you count by 3s, your third hash mark's the larger one, just something you need to put to memory. One side note I do want to add here, a word of caution. When you're dealing with volume in particular, let's say we have something like this. Let's say we have 850,000 cubic centimeters. And let's say, let me fix this here. So 850,000 cubic centimeters. And I want to convert that to cubic meters. Okay? Common mistake someone would make would be, okay, here I am at centimeter. Right here, and I want to go to meter, and they go 1, 2 loops to the left, and they do the same thing on their answer over here, and they get the wrong answer. And what's up with that? Well, they failed to realize when you're dealing with volume, you have 3 dimensions you're looking at here. It's not a very good box. You get the idea. You got your length, you got your width, and you got your height. You've got to move the decimal 2 loops for each of these dimensions, for a total of 6 loops. So if I'm going from cubic centimeter to cubic meter, I need to do that for each of those dimensions. So my final answer is going to look something like this. 2 loops for the length, 2 loops for the width, 2 loops for the height, and then my final answer is going to be 0.85, you don't need the other zeros on there, cubic meters. And there you go. So just a word of caution when you're dealing with volume. Same thing applies when you're dealing with area, except you would just do it for the length and the width. You'd move your decimal for each of those dimensions. Well, I hope this helps. Once again, make sure you put this to memory. A lot of my students just write this at the top of their exams and quizzes or labs or whatever, just as a handy reminder on how to convert between the units. In particular, this is what we do a lot in with labs. So hope this helps, and have a great day. And we'll see you all in class.